Hello everyone and welcome to the last part of this discussion, which is geologic formations as aquifer part 3, and we will try to complete this discussion on geologic formations as aquifers. So, as we have been discussing about sedimentary rocks in a previous section, starting from alluvial, which is made of sand and conglomerates, then limestones, then shales and other things. Now, we are here, we will be discussing about volcanic rocks as aquifers, how good they are, how bad they are, where they are located and so on. Few times I have mentioned in previous discussions about Deccan trap flows or Deccan areas or basaltic terrain of India. So, here the igneous rocks which are exposed on surface occupies a large part of India, which is shown on the right figure, which is the green part of India, which you can see here also in this legend. So, this large part which occupies large part of Maharashtra, almost 85% of Maharashtra, large part of Madhya Pradesh, and then almost full part of Saurashtra, it is located. Deccan trap is also in the Arabian Sea, which is near to Indian coastlines, that is also there. But from groundwater point of view, we will be not discussing the Deccan traps which is located in the Arabian Sea, but only on the land part located in India. So, volcanic rocks which we are seeing here as one of the volcanic rocks is basalt, and it can form highly permeable aquifers. Now, when we say highly permeable aquifers, that means we are expecting that these rocks or these formations are having lot of vesicles, because these are extrusive igneous rocks. So, when the lava comes on surface, it cool down very quickly as compared to rocks which are formed underneath like granite and other rocks. So, here if there is interconnectivity is available because of gas has escaped, and whether the interconnectivity is there, if that is there, then these rocks can become highly permeable aquifers, and they can provide or store good amount of water. So, basalt flows, earlier also I have said in some parts of India 40 different types of basaltic flow have been identified. Generally they are horizontal in characteristics, and if we go towards the origin, there are two theories. One says that there must have been a volcano, big volcano, which has allowed this kind of extensive basaltic or Deccan trap area, or some other theory says this is because of fissure, that is why it has occupied a large part. The typical vents, some people claim that they have identified volcanic vents as well. So, if we do not consider that or do not concentrate on origin of basalt, but whatever present from groundwater point of view, which we will be focusing our discussion. So, basalt flows in particular inherent such characteristics, that is the permeable aquifers or high permeability. And other volcanic rocks, for example rhyolite, are less permeable than basalt, because these rocks might not have those vesicles and connected vesicles. As some of the basalt rocks are having deposition of secondary minerals in those vesicles, and that means they are reducing the permeability, porosity as well as permeability. But in large part of basaltic terrain, you do not see that kind of little older parts, or the flows which came first are having secondary mineral deposits. So, Indian examples of course basaltic terrain is Deccan trap, and you can see here that these are the almost horizontal layers, and you can even count number of layers. They make very famous tabletop kind of topography in many parts of Maharashtra. So, if you go to Mahabaleshwar area and other things, tabletop topography is very popular and very attractive for tourists also. So, those rocks are basaltic rocks, and we know that these are the stratified like sedimentary deposits, because flow after flow came and they got deposited layer after layer. And there are chemically, if you start analyzing, there are variations also in these layers. That is why they can be distinguished very easily. The plant also grows little differently on the different layers. And these various layers will have different properties, chemical properties, and the basalt flows are interbedded with ash flow tuffs. So, it is not necessary that one layer came and there were some gap or ash came, volcanic ash, and that make this ash flow tuffs, and then there were some gaps. There might be some sedimentary depositions also, intertapian beds, and then again a fresh this basalt layers or basalt flow has come or lava flow has come. So, because it has this activity went for many years, and therefore, such interbedded sedimentary rocks can also be found, or they have been found. Some are even having fossils as well. So, this you may have ash flow tuffs and other things. It is not that continuously you are having all basaltic rocks. So, that means these layers are having different hydraulic properties, and of course, they will respond differently depending on fracturing which is there. Sometimes the cooling joints is more brittle basalt will not propagate there into tuffs. So, it depends on the cooling, how much supply of lava was on the surface, and how much fracturing has occurred now because of some erosional weathering properties, or might be some tectonic activities as well. So, these are various types of openings which one can find in basaltic rocks, volcanic rocks, that are cavities, cracks, gas vesicles, very common, which is one of the criteria to identify such rocks also, because these are otherwise very fine grained rocks are there. So, when we get lot of vesicles, some vesicles are filled with secondary material or secondary minerals, we can easily find volcanic rocks, and which contributes toward the permeability of basalt aquifers. So, these cavities, cracks, gas vesicles, fissures, these are all favorable from permeability point of view or from groundwater point of view. Now, we come to the last type of rocks, that is igneous and metamorphic rocks. I have put both in the same category rather than putting separate like sedimentary rocks or volcanic rocks, but here volcanic rocks are also igneous rocks, but here I am putting it completely in a separate category, those igneous rocks which are hard, and they are not extrusive igneous rocks, they are abyssal or intrusive igneous rocks like granite. So, basalt is of course igneous rocks, but we can deal with completely differently because they are having good permeability, not like granite or other metamorphic rocks. So, which are not good for aquifers. So, some of the basalt may not be also good for as aquifers, they may not have good permeability. So, these rocks tend to have low primary porosity, because like granite or other metamorphic rocks will not have a high porosity, or even primary porosity means at the time of formation of these rocks. But later on the porosity may develop because of weathering activities and some fracturing and other things. So, further the porosity is not often not well connected. So, you might be having porosity, but if it is not connected, that these rocks cannot become good permeable rocks either. Permeability would be poor in these kind of rocks. When these are these rocks, our igneous and metamorphic rocks or hard rocks, let me call them hard rocks, when they are exposed to weathering or to the surface and all kinds of rain, heat and vegetation activity, biological activities through the weathering, because there can be a biological weathering also, chemical weathering also. So, when these rocks are exposed to the weathering, all kinds of weathering or subject to fracturing, then these rocks may develop permeability. You know that sometimes whenever there is these rocks on surface are exposed to the sun, especially in summer time, and the top part is very hot, and suddenly there is a rain, then this rain can develop fracturing, and this demonstration of this thing I have seen few years back near along the Ganga river in Lakshman Jhula area, upstream of Lakshman Jhula bridge, and where I saw some labor were trying to break a big boulder. So, first they were heating that boulder from whatever the wood they had, or pieces of bush and dry bush and other things for about 2-3 hours. And then suddenly they brought the cold water of Ganga and put over that. So I asked them, what are you doing like this? So they said, we would like to break this boulder, and this way we can break boulder very easily, because if a rock is hot and suddenly you put cold water over it, it will develop fractures, and then the rock can get disintegrated. So heat and water, and of course the vegetation, animals, they play major roles in weathering and can create fractures also. So in general, the productivity of these aquifers is almost always depends on fractures, because these are hard rock terrains. If they do not have fractures, like if you go deeper in these, like granitic terrain, I have seen some granite mines also. Of course, these are open cast mines. So if you go 20-30 meters deep in these mines from the surface, you would find that these rocks do not have any kind of fractures. So only on the surface these rocks are weathered, having fractures, and they become a completely unconfined aquifer conditions. But these thickness of this aquifer, unconfined aquifer, generally is not much, maybe only few meters, and that makes the availability of water in these regions very challenging. And we have seen the maps that large part of India is having hard rocks of granite and metamorphic rocks. Anyway, so this if some tectonic, generally in these areas also you do not have much tectonic activities as well, and granitoid regions or metamorphic terrain. But if they are there, like tectonically dominated regions which are having hard rocks, then the fractures will often follow fairly distinct orientation based on the structural history of the area. Let me give you one example, and this how it has been exploited from groundwater point of view, which will also come when we will discuss where to find groundwater and where to recharge groundwater, especially in granite terrain like in Bundelkhand Craton. So I am giving an example about this tectonic activity and then what happened during structural history of the area. One of the hypothesis says that because there are large quartz reefs of having very, compared to today's ground surface, many are having even height of 20 or 30 meters, and these are made from quartz, and the surrounding rocks are of course granite, Bundelkhand granites are there. And these quartz reefs are running in northeast southwest direction for hundreds of kilometers, and they might be wide of even 20-30 meters, but they are running continuously or intermittently in northeast southwest direction, and there are successive such quartz reefs are there. So one of the hypothesis says that there were some tectonic, huge tectonic activity occurred, which develops these large fractures into the granite, and later on the granite came. Now there will be a question how these are standing out compared to what granite is there. So one should be knowing that granite is made from quartz feldspars plus minus mica, and this terrain or this Bundelkhand granite, gneissic complex some people also call, it is made from quartz, feldspars, and of course biotite is also there. So feldspars and biotite are relatively highly weatherable as compared to quartz, and therefore the surrounding rocks or the host rock, which is a granite, got weathered because of sun activities, temperature, water and other things. But the quartz, which is having relatively very high resistance to weathering, stood, and therefore these serves as a barriers also from groundwater flow point of view. But at the same time these quartz reefs have been used as a dam axis for groundwater recharge as well. So this I will be showing in our future discussions, an extensive discussion on this kind of a tectonically or having area having a structural history, and how we can exploit these quartz reefs from our benefits in the current times. Now another type of sediments or rocks which clay, which makes clay stone. So clay, and which is a very fine material, and some other coarser materials mixed with clay are generally porous. So, it is said many times that clay is porous, but very poor on permeability front. But their pores are so small that they may not regarded as relatively impermeable, because the surface tension and other things will play very important role when the pore spaces are very small, and therefore, the porosity, not only porosity matters, but the pores have to be large enough that the water can flow through it. That is what our permeability is getting affected. So, clayey soils can provide small domestic water supplies from shallow large diameter wells. Large diameter wells, that means you are opening a large surface area, so that water will enter into the well and then you can pump out the water. But generally these are the areas which are challenging from groundwater point of view. Now, if we see that basins from groundwater basins point of view, that hydrogeologic units, which is we can define groundwater basins, that hydrogeologic units containing one large aquifer or several connected and interrelated aquifers is known as groundwater basin. So, there are basins which are like Indo basins or Indo-Gangetic basins, which is one of the best examples of this. So, some such basins may or may not coincide with physiographic units, means with the topography or other things, but generally they are there. So, here it is shown that the valleys are there, the main river is there, then there are rocks and surrounding hills are there. So, main channel is there, and it has created a conditions which are favorable from groundwater point of view, and we can call them as groundwater basins. So, in valley between two mountains or ranges, the groundwater basin may occupy only the central portion of the stream drainage system, as you are seeing on the right figure. So, these flood plains are of course very good from groundwater point of view, and if it is running for long distances, no problem. So, in earlier discussion we were discussing about infiltration wells or wells, riverbed wells, which are withdrawing water from river. They are all in this part which is filled with alluvium and which makes the floodplain of a river. In hilly areas, this floodplain or this alluvial filled valleys are narrow relatively, but still in some parts they are there. And if you travel in Himalaya, because generally Himalayan roads are all along the valleys. So, you may find at places that you are having big these riverbed wells or infiltration wells also. So, for water supply and recharging point of view also. So, in limestone and sand hill areas or sandstone areas, drainage and groundwater basins may have entirely different configuration as compared to other geological setups, and the concept of this groundwater basins becomes important because of hydraulic continuity. If these are continuing or interconnections are there between the basins, they becomes very useful, exist for contained groundwater resources. Now, if we do not call them exactly groundwater basins, just call them basins, and you know that there is a interconnection of rivers, projects are going on, and recently one river in central India, that is Betwa and Ken river, these are being connected, and this connection between these two rivers will provide a canal, and that canal can serve as for irrigation purposes. So, large part of that part of India will be irrigated through that canal. So, these are the interconnections between basins is being established. So, we can also put them as groundwater basins also, because the large part of if water is coming from one river to another, from where this connection will be established through canals, that will also get irrigated. So, that can also become a groundwater basins all along that region where the canal systems is being developed. So, in order to ensure continued availability of subsurface water or groundwater, basin wide management of groundwater becomes essential, because if there is an interconnection, fine. If there is no interconnections, still the basin wise, because one basin may have different geological setup as compared to the adjacent basin, or both basins might have same geological setup, but topographically they are different. So, their management is really essential in all these regions. As shown here in this figure, that groundwater basins are the regional groundwater flow systems. So, in between you are having valleys, and you know that like intermediate flows are there. Here you are having local flows, here also you are having local flows. But the overall regional flow goes like this, and it appears in the stream. So, local and regional recharge is happening here, local and intermediate recharge is happening here, local discharge is happening. So, there is a springs are also there, and then local recharge because of hill or interception by vegetation, then local intermediate discharge is happening. Again here a stream might be there through the springs, or origin might be springs, and local recharge, and then finally local regional discharge is there in form of streams. So, this is a this kind of geological setup or topographic setup and physiographic setup can be seen in Himalayan conditions. A very common kind of setup is there, which shows the regional groundwater flow systems and can comprise such systems at different scales and complex hydrogeologic frameworks. So, in one valley, in one part you may be getting water, another part you may not. So, suppose if I make a well here, I may not get the water, but if I make a groundwater well, I will get the water. Here also I will get the water easily. So, these things have to be, they are complex, but these have to be studied before any drilling is made. Regional groundwater flow also matters, as whenever you are having such topographic arrangements. One example I have already given about Himalaya and Indo-Gangetic plain, and in other parts of India where hills are there, they also are having like on the left figure which we are seeing, that these are the primary recharge areas where when the hills or the water is coming over the ground and reaching at the ground level, or alluvial plains like Bhabbar zone of Indo-Gangetic plain, then you are having a secondary recharge areas. There are again intermittent valleys are there, and then discharge areas are there. So, these should be investigated, that from groundwater exploitation point of view, you may have a situation where you can have a confining bed and confined aquifer conditions. You are having unconsolidated alluvial plain over this and that kind of thing. And of course, the mountain is there on the one side. Similarly, here also on the right figure you are having primary recharge area, then you are having secondary recharge area. If there are lot of rocks layers are there, and then you are having like here sandstone you are having, and then you are having other rocks also, and sandstone also, alluvial fills also. So, this the blue part is the most favorable from groundwater point of view. So, a regional groundwater flow system, if basin from basin point of view, if groundwater basins are studied, then the management as well as exploitation from groundwater point of view becomes much easier, and therefore, it is very important to study first at a regional level, what is the regional setup from groundwater point. So, in the regional groundwater flow system, recharge areas all along groundwater divides, discharge areas like bottom of major drainage basins, which you have seen in these two figures. There are some other examples of regional groundwater flow systems where you are having losing streams, gaining streams, and submarine groundwater recharge, and maybe in as we have also discussed in limestone terrain. So, local groundwater flow systems, intermediate groundwater flow systems, and of course, this the lower part is showing regional groundwater flow system. But not all types of groundwater flow are present in every aquifer systems. There may be like local or regional or intermediate, but not all in all setups, all geological or topographic setups. Regional flow systems are less transient, and then local and intermediate flow systems. Means the changes in the ground from groundwater point of view, the changes are not as we witness in case of intermediate and local groundwater flow systems. Further we see here, which now we are coming to end of this discussion about the last part of our geologic formations as aquifers, and here also this we are continuing our discussion on regional flow systems. One section, cross section has been seen earlier, we have been seeing in 3D perspective. So, here we can see that how water is flowing. So, if it is a regional recharge on one end, this is regional discharge on another end. So, water will flow from here, and here topographically this is the higher areas, and if it is forested area, then that can become a very good recharge areas because of interceptions of water, and this forest plants will intercept, they will reduce the surface runoff, they will allow water to enter in or water to percolate and go in the groundwater regime and so on, and then they will come on the surface. However, if there are some rocks by which they can react, the water may react, and you may have saline soils or wetland halophytes also. Sometimes you get when you are discussing or thinking from regional groundwater flows also. So, there are different kind of plants can also there are xerophytes plants are there, ferritophytes plants are also there, and you may get springs as well, which is a result of might be a local groundwater flow systems. So, that regional flow systems are minimally affected by seasonal variations by in groundwater recharge and are capable of providing fairly consistent source of discharge or water into the well to streams which will sustain groundwater discharge. So, this kind of setup is very common in hilly regions. If I talk about Himalaya, of course, very common there. So, with this I end this third part of our discussion, that is geologic formations as aquifers. Thank you very much.